The RETScreen clean energy management software can be used to evaluate various types of power, storage, and off-grid projects. Photovoltaic, wind, reciprocating engine generators, hydroelectric, and battery storage can be included. There are a number of ways to get started with the model, including several case studies and templates, many archetypes in the Virtual Energy Analyzer, and even this shortcut button on the home page, which quickly loads an example analysis you can examine. I'll start with the Virtual Energy Analyzer, which is a way to configure RETScreen with values relevant to a particular project scenario, referred to as an archetype. An archetype can be a convenient starting point when the scenario to be analyzed resembles the archetype. For example, you might start the analysis of a high-rise apartment building with the corresponding archetype. If the archetype is similar to the project you want to analyze, the values RETScreen selects for inputs to the analysis may be appropriate for your project and only need minor refinements. As usual in RETScreen, the archetype compares a base case, typically corresponding to a conventional approach using fossil fuels, and a proposed case, typically an approach that reduces the consumption of conventional fuels. The benefits and costs of the proposed case are calculated in comparison to the base case. The Virtual Energy Analyzer can be launched from the home page using the button found under Getting Started Options. I need to first indicate that I am looking for a power storage off-grid archetype. Then I indicate the type of technology that will be used in the proposed case. Here, I'll select photovoltaic. Next, under Description, I specify three things: the size of the load in kilowatt hours per day, the power system that is assumed for the base case, and the power system that is being examined in the proposed case. We see that in this list. For a base case consisting of a genset, that is, an engine driving a generator, to which we are comparing a proposed case consisting of a PV array plus a battery, there are archetypes available for loads of 240 watt-hours per day, 2.4 kilowatt-hours per day, etc., up to 240 megawatt-hours per day. Looking at this drop-down list, I can see the various types of off-grid photovoltaic system scenarios that RETScreen can model. There are archetypes to compare PV plus battery plus genset, or PV plus genset without battery systems, to a base case consisting only of a reciprocating engine genset, a genset plus battery cycle charging system, or extension of the electric grid to the site. For sites already serviced by the grid, there is an archetype to compare a photovoltaic plus battery system with grid backup to relying on the grid alone. There are also archetypes for four specialized applications: one for very small DC loads, such as might be found in rural electrification, another for a seasonal chalet or cottage, typically being used mainly during the summer, and two water pumping archetypes, one for irrigation and the second for livestock. Those are the archetypes with photovoltaics as the proposed case. There are also archetypes for when the proposed case is one or more wind turbines. As for PV, the base case system, proposed case system, and load define the archetype. There are archetypes that compare wind plus genset or wind plus battery plus genset proposed cases to genset, genset plus battery, or grid extension base cases. As for PV, there is also an archetype for sites already serviced by the grid, where the grid is used as backup to a wind plus battery system in the proposed case. Let's look at an archetype using photovoltaic technology, with the base case being a genset and the proposed case being a photovoltaic plus battery system. We'll assume a 1 kilowatt average load, which corresponds to 24 kilowatt hours per day. The load will affect everything in the archetype from sizing to costing, but you can and should modify the values to reflect your specific project. For example, a typical off-grid house will consume between 2.4 and 24 kilowatt hours per day. I'll assume that it is closer to the latter, but would need in reality, to adjust key inputs to reflect my estimate of the house's load. Finally, I need to specify the location of this project. I'll choose a location in northern Canada, near Teslin, Yukon Territory, and assume that I am providing power at an off-grid site. I click on Calculate, and the model opens with inputs selected for systems satisfying a 24 kilowatt-hour per day load near Teslin. The location worksheet has climate data for the site, as would be found in any RETScreen analysis. The facility worksheet indicates that this is a feasibility study for a power storage off-grid facility. The proposed case uses photovoltaic technology, and specifically a photovoltaic plus battery system to satisfy a 24 kilowatt-hour per day load. This is compared with satisfying the load with a genset alone in the base case. At the bottom of the facility worksheet, there is a benchmark section similar to that found for on-grid power systems. It shows the range of energy production cost, which is one way to calculate the levelized cost of electricity, typically seen for off-grid power systems of different technologies. There is also a benchmark that you can adjust. The technology that is selected in the current analysis, off-grid photovoltaics, is highlighted. Hovering over a bar on the graph displays the typical minimum and maximum energy production costs, covering a wide range of scenarios. On the energy worksheet, there is a notes section which describes the archetype's assumptions in some detail. In the electricity and fuels page, we find the assumed price of diesel, which we can adjust. Natural gas and electricity are included by default, but are not used in this archetype and can be ignored. Using the navigation bar on the left, I select the page with parameters describing the base case power system and the load characteristics for both the base and the proposed case. I can see that a diesel-fired reciprocating engine provides electricity in the base case. The load is specified simply as 24 kilowatt hours per day of AC electricity. I can adjust this value to match my particular case, but keep in mind that the archetype's sizing of the components will not automatically update, so you will have to adjust those also. To avoid that here, I'll go back to 24 kilowatt hours per day. If you wish to specify the load in more detail, you can select Method 2 and provide a list of individual loads and their characteristics in terms of AC or DC, power, and hours per day and hours per week that they are on, and their intermittent resource load correlation, which I'll explain in the next video. Note that this is different from on-grid power systems, where the archetype is defined solely by the proposed case generating capacity, and it is not essential to select the base case system since it is assumed to be the grid. The on-grid model will then calculate how much electricity the on-grid power system generates over the course of the year. That approach does not work for off-grid systems, however, because typically there will be a defined load that must be satisfied, and the generating capacity, storage, and backup generators must be sized in consequence of that load. I use the navigation bar on the left to examine the components in the proposed case. There is an inverter to convert the DC output of the photovoltaic array or the battery to AC, a battery with 2.5 days of autonomy, and a photovoltaic array. If you are unsure what a parameter refers to, try clicking on the name of the parameter to open RETScreen's help. For example, within the parameters for baseload photovoltaic, for azimuth, I see that the value of 0 selected here indicates a PV array oriented towards due south. These components have been dimensioned to provide nearly 100% of the electricity required by the load year-round. Since there is some unmet load, which might require a peak load system, a triangular yellow caution sign is displayed by RETScreen. We can see that from February through November, the PV plus battery system can fully satisfy the load under typical climatic conditions, but the caution sign for December and January flags those as months when there is unmet load. If this were unacceptable, we could add a peak load power system by clicking on the button in the ribbon bar and specifying its parameters. I do not wish to include a reciprocating engine genset or other peak load option in this analysis, so I'll eliminate it by right-clicking on the relevant item in the navigation bar and selecting Delete. Alternatively, I could increase the size of the photovoltaic array, battery, or both in order to satisfy the unmet load. You may have noted that component costs can be included on many of these pages. The $sign button opens a cost database which can provide a first estimate for these costs. For batteries, for example, the cost database provides minimum, maximum, and average values for typical installed costs per kilowatt hour of storage capacity for a number of different battery technologies. The table also includes information related to operating and lifetime characteristics of the technology, which can help select the appropriate type of battery for a given application. The remaining worksheets will be familiar to anyone who has used RETScreen for pre-feasibility analysis. For this archetype, the cost worksheet provides a level 2 analysis, including periodic costs for battery and generator replacement. The emissions worksheet contains a level 1 analysis. Though simple, it reflects the emissions from consumption of diesel in the base case. The finance worksheet has a level 2 analysis with the same parameters and outputs as an on-grid power project. At the top of the risk worksheet, there is a sensitivity analysis, which communicates the sensitivity of financial outcomes like profitability or payback period to combinations of two key variables, such as the initial costs and O&M costs. At the bottom, a risk analysis communicates the sensitivity of financial outcomes to simultaneous variation in a larger set of key variables. The resulting impact graph can help identify the variables that most strongly influence financial outcomes. Here, those would be the initial costs and fuel costs in the base case. One should check particularly diligently the assumptions made by the virtual energy analyzer for these critical parameters. In addition to the archetypes accessed through the virtual energy analyzer, there are case studies and templates built into RETScreen. The bank of case studies and templates can be accessed from the Open page on the File worksheet. The button under Getting Started Options is a shortcut to that. Whereas the archetypes are typically configured by RETScreen according to parameters the user supplies, the case studies and templates describe a single project at a particular location. Clicking on the blue hyperlink in the leftmost column opens a text description of the project. Case studies differ from templates in that they are generally based on real projects. If a case study or template project is similar to the one you are contemplating, it can serve as the starting point for the analysis. Double-click on the desired row in the table to open the RETScreen analysis. In addition to the virtual energy analyzer and the bank of case studies and templates, a generic feasibility study can be opened with the Feasibility button under Getting Started Options on the home page. In the following videos, I'll look at other archetypes for the power, storage, and off-grid model, modify more input variables, and present other features of RETScreen.